Understanding the correct type of protection for a branch circuit with a fan motor, rated at 2 horsepower, 230 volts, 3-phase, and controlled by a frequency drive involves several considerations based on the National Electrical Code, or NEC. The NEC provides guidelines to ensure safety and proper operation of electrical equipment. The common protection methods often debated are using a combination motor starter, a fuse and contactor setup, or a breaker and contactor arrangement. Let's delve into the details to clarify the requirements and how to prove the correct method. Firstly, it's crucial to understand the roles of each component. A motor starter typically includes overload protection and a disconnecting means, often a contactor, all within a single unit. Overload protection is designed to protect the motor from overheating due to excessive current draw over time, while the disconnecting means allows for safely cutting off power to the motor for maintenance or in emergency situations. Fuses and breakers, on the other hand, provide short circuit and ground fault protection, interrupting the circuit when a fault condition occurs to prevent damage and hazards. A contactor is an electrically controlled switch used to energize or de-energize the motor. When a frequency drive, also known as a variable frequency drive or voltsd, is involved, it introduces another layer of complexity. The voltsd controls the motor's speed by varying the frequency and voltage supplied to the motor. This can improve efficiency and provide precise motor control. Now let's discuss the relevant sections of the NEC that govern motor circuit protection. Article 430 covers motors, motor circuits, and controllers. This article provides detailed requirements for motor circuit conductors, overload protection, short circuit and ground fault protection, and motor control equipment. Specifically, Section 430.52 addresses the rating or setting for individual motor circuit, short circuit, and ground fault protective devices. This section dictates the maximum allowable rating or setting for fuses or circuit breakers used to protect the motor circuit. The maximum rating or setting depends on the type of motor, its design letter, and the type of protective device used. For instance, inverse time circuit breakers typically have a higher allowable setting compared to fuses. Section 430.110 covers disconnecting means. A disconnecting means is required to safely disconnect the motor and controller from the power supply. This can be a switch, a circuit breaker, or a motor starter with a disconnecting means. The disconnecting means must be readily accessible and capable of interrupting the motor's locked rotor current. Section 430.122 addresses adjustable speed drive systems. This section provides requirements for the installation and protection of volts and their associated motor circuits. It emphasizes the importance of protecting the volts and motor from overcurrent, short circuits, and ground faults. Let's consider the scenario with a 2 horsepower, 230 volts, 3-phase motor and a voltsd. To determine the appropriate protection, we need to calculate the motor's full load current, or FLA. The FLA can be found on the motor's nameplate or in NEC Table 430.250 for 3-phase motors. For a 2 horsepower, 230 volts, 3-phase motor, the FLA is approximately 6.2 amps. Next, we need to select the overload protection. According to NEC Section 430.32, overload protection is required to protect the motor from overheating due to prolonged overcurrent. This protection can be provided by overload relays in the motor starter. The overload relays should be sized no greater than 125% of the motor's FLA for motors with a service factor of 1.15 or greater, or with a temperature rise of 40 degrees Celsius or less. For motors without these characteristics, the overload relay should be sized no greater than 115% of the FLA. In this case, assuming the motor does not have a service factor of 1.15 or greater or a temperature rise of 40 degrees Celsius or less, the maximum overload relay setting would be 1.15 times 6.2 amps, which equals 7.13 amps. Therefore, the overload relays should be set at or below 7.13 amps. Now let's address the short circuit and ground fault protection. As per NEC section 430.52, the maximum rating or setting of the short circuit in ground fault protective device, such as a fuse or circuit breaker, depends on the type of device and the motor's design letter. Assuming the motor is design letter B, which is the most common type, the maximum allowable rating or setting for an inverse timed circuit breaker is typically 250% of the motor's FLA, and for a fuse is typically 175% of the motor's FLA. For an inverse timed circuit breaker, the maximum rating would be 2.5 times 6.2 amps, which equals 15.5 amps. Therefore, a 15 amp circuit breaker would be suitable. For a fuse, the maximum rating would be 1.75 times 6.2 amps, which equals 10.85 amps. Therefore, a 10 amp or 12 amp fuse would be appropriate, depending on the available standard sizes and the specific fuse characteristics. It's crucial to note that the voltsft also requires protection. Most volts have built-in protection features such as overcurrent, overvoltage, and undervoltage protection. However, it's still necessary to provide upstream protection to protect the voltsft and the motor circuit. The voltsft manufacturer's specification should be consulted to determine the appropriate size and type of protective devices. Typically, the manufacturer will specify a maximum fuse or circuit breaker size for the voltsft input. Considering these factors, a combination motor starter with appropriately sized overload relays and a circuit breaker or fuses provides comprehensive protection for the fan motor and voltsft. The motor starter provides overload protection and a disconnecting means, while the circuit breaker or fuses provide short circuit and ground fault protection. The voltsft manufacturer's recommendations should be followed for additional protection requirement. To prove that a motor starter is sufficient, you can present the following arguments. Firstly, demonstrate that the motor starter includes appropriately sized overload relays that comply with NEC section 430.32. Provide calculations showing that the overload relay settings are within the allowable limits based on the motor's FLA and service factor or temperature rise. Secondly, show that the circuit breaker or fuses protecting the motor circuit comply with NEC section 430.52. Provide calculations demonstrating that the breaker or fuse rating is within the allowable limits based on the motor's design letter and the type of protective device. Thirdly, provide documentation from the voltsft manufacturer specifying the recommended fuse or circuit breaker size for the voltsft input. Ensure that the selected protective device meets or exceeds these recommendations. Fourthly, highlight that the motor starter provides a disconnecting means as required by NEC section 430.110, allowing for safe disconnection of the motor and controller. Fifthly, emphasize that the combination of overload protection, short circuit and ground fault protection, and the disconnecting means provides comprehensive protection for the motor, voltsft, and the motor circuit, meeting the requirements of NEC Article 430. In summary, selecting the correct protection for a fan motor with a voltsft requires careful consideration of the motor's characteristics, the voltsft manufacturer's recommendations, and the requirements of NEC Article 430. A combination motor starter with appropriately sized overload relays and a circuit breaker or fuses provides a robust and compliant solution. By presenting calculations, documentation, and a clear understanding of the NEC requirements, you can effectively demonstrate the sufficiency of a motor starter for this application. Additionally, it's important to consider the specific installation environment and any unique requirements that may influence the protection scheme. For example, if the motor is located in a hazardous location, additional protection measures may be necessary to comply with NEC Article 500 and subsequent articles. Furthermore, coordination between the various protective devices in the motor circuit is crucial to ensure selective tripping. Selective tripping means that the protective device closest to the fault should trip first, minimizing the impact on the rest of the electrical system. This can be achieved through careful selection and coordination of fuses and circuit breakers with different time current characteristics. In practice, it's often beneficial to consult with a qualified electrical engineer or a licensed electrician to ensure that the motor circuit protection is properly designed and installed. These professionals have the expertise and experience to assess the specific application requirements and select the appropriate protective devices and control equipment. They can also perform calculations to verify that the protection scheme complies with the NEC and other applicable standards. Moreover, regular inspection and maintenance of the motor circuit protection equipment are essential to ensure its continued reliability and effectiveness. Overload relays, fuses, and circuit breakers should be periodically inspected to check for signs of damage or deterioration. Testing of the protective devices should also be performed to verify their proper operation. It's worth noting that advancements in motor protection technology have led to the development of intelligent motor protection relays that offer advanced features such as motor monitoring, diagnostics, and communication capabilities. These relays can provide early detection of motor faults, allowing for proactive maintenance and preventing costly downtime. They can also be integrated with built-in automation systems to provide remote monitoring and control of motor circuits. When specifying motor protection equipment, it's important to consider the overall system requirements and the potential benefits of incorporating advanced features. However, it's crucial to ensure that the selected equipment is compatible with the existing electrical system and that it complies with all applicable standards and regulations. In conclusion, ensuring adequate protection for a fan motor operating with a volt necessitates a comprehensive approach, encompassing adherence to NEC guidelines, proper sizing of protective devices, consideration of the volt specifications, and regular maintenance. The combination of a motor starter with appropriately selected overload relays and short-circuit protection, coupled with professional consultation and ongoing vigilance, forms a robust strategy for safeguarding the motor, the volt, and the overall electrical system. Remember to always consult the latest edition of the NEC and any relevant local codes and regulations when designing and installing motor circuit protection. Understanding the fundamental principles and applying them diligently will contribute to a safe, reliable, and efficient motor control system.